Hi everyone and welcome to Cybersecurity Career Talks. I am Niloufer Tamboly, your host, your coach, your teacher on this journey with you as we explore different careers in cybersecurity until you find your dream job. I have with me today Mitesh Shah. Hi everyone and welcome to Cybersecurity Career Talks. I am Niloufer Tamboly, your host, your coach, your teacher on this journey with you as we explore different careers in I have with me Mitesh Shah, who's a mobile security expert, and Mohan Yelnadu, who is an AppSec expert and a big supporter of the show. Thank you, Mitesh and Mohan. And I'm just going to share my screen. Okay, but before we start, there's a disclaimer. The views expressed in this presentation and during the session are the personal opinions of the participants and do not reflect the official policy or position of their respective employers. This discussion is a volunteer-led effort to contribute to the profession and pay forward the many kindnesses and instances of support and guidance that the participants have received in the course of their career. So this is part 3 at API security. We've covered mobile device security and mobile app security in the previous videos. So if you've not, this is the third part, which is we are going to deal with API security. So if you've not seen those videos, please go and see them. And if you just are interested in to learn about API security, then this is the video to watch. Thank you so much. So Mohan.
Yeah, sure. Let me actually kick off and then Mohan will come in. So as Niloufer mentioned, we had a 3-part series. The first session was focusing on the mobile device security. So we were kind of like providing guidance foundation up, so that if someone has to wants to transition the career, or if they are in this area and want to enhance their knowledge, then how to go about doing it. And so the first session was starting from the device security itself, and then on top of it, building further in the second session was the mobile app security. So as the apps get developed, how do we protect data and the application security itself? Today's session is around API security, because if we look at the full ecosystem, you have mobile devices, then apps running on it, but there is always some kind of backend behind those apps. And that's where the API comes into picture with this current trend of Azure development, microservices architecture. APIs are imminent in this mobile ecosystem, and you will see that every mobile app has some kind of interaction with the API backend. So that's what we are going to focus on today. So this way, as a mobile app security specialist, you should also have knowledge about the backend components, and that's where the mobile security meets the traditional app security. So that will be the focus of today's session. Let's go to the next slide. So as far as the app security, just a refresher here, we gave several resources on how to go about what exactly type of skill set you need in order to transition into this career, or as a mobile AppSec expert, what are some of the industry best practices that you should learn. And these resources are listed here, so I'm not going to go every one of them, but that's just a refresher from the previous session. So let's go to the next slide. Apart from that, we talked about both sides, the controls and best practices, but at the same time, as a practitioner, the best way to learn about is understand the threats. What are the risks that we are we can potentially have, and that will help you understand what type of controls or the knowledge that I need to build in order to provide the best guidance as a security practitioner. And the MitraTech Framework is one of the best resource I use very frequently personally in my job, and this is the resource that highly recommended that everyone who is interested in this area should look at. And it will give you from both mobile perspective as well as some of the backend component, and that's where it will apply to the API security, some of the threats that are listed here. So just from the overall threat model perspective, you have a mobile device, and usually people are behind data, right? So a just device itself does not have much value other than from the business perspective. But when you put the data on it, it has significant value, right? So you have email, you have messages, you have several enterprise applications. So that's the data. But there are, in the overall threat model, there is a middle component, which is the network security, where mobile device connects to the backend server. But then most importantly is the backend. And that's where the API in current days is heavily leveraged, because it just directly deals with the data. And the UI layer is kind of addressed at the mobile app itself. So when you combine that together, that's where the business functionality comes into life. So if we just focus on the mobile device and app security, it is kind of like half the picture. In order to complete the full picture of the threat model, that's where we are introducing today the API security part. So I'll let Mohan take it from here. On your mute, I think.
Yeah, sorry. Thank you. Can we go to the next slide, please? Sure. So thanks, Mitesh, for setting the context here. Last session was on mobile app security. So this slide is kind of a transition slide, I would say. As Mitesh rightly said, you have mobile device and security, then you have mobile app security, and then just the app and the mobile is not an attractive bait for hackers, actually, right? Unless they connect to a backend server where the enterprise data is there, right? So when we talk about mobile app security, we basically talk about what is there on the app itself, anything sensitive, like it could be hard-coded API keys, it could be clear storage of API-based credentials, or weak implementation of JWT tokens, used for authorization or other purposes, right? So anything that is found on the mobile native app is actually a big starting point for hackers, to take it and then further propagate that exploitation to the backend, right? Apart from that, from the mobile app security and API security, what is critical is the data, about the device, about the user, that is being sent transparently. That means without the knowledge of the user, the app user, to the third parties. And sometimes it happens via some of the framework APIs, some of the open source modules that are built into the mobile app, or from the other apps which are actually trying to listen to all this, whatever is that is possible to get the hands on and share it with third party. So this is basically what is covered from API security as well as mobile app security. So now on, we'll now focus only on the API security side. Yeah, over to the next slide. Now, before we go ahead, I think it is, and understand more about API security domain, we need to understand what are the major challenges that, we are facing currently. So the first and biggest challenge is the inherent nature of the API domain itself. Why I'm saying inherent domain? Because if you see, compared to other software development components, APIs are relatively new. I would say around a decade old, and that has that has brought out more challenges, especially because the dev community itself is not fully aware of. They are aware of API development, but they are not fully aware of secure API development. And that's where the challenge is actually. Apart from the maturity of the development community, we also have the scarcity of API security skill set available in the market. And these two combinedly actually bring a very big challenge, for the API security domain. The next big challenge is the technology landscape that we have in the API ecosystem. So we have a complete variety, starting from legacy web services, XML-based services. We have SOAP, REST, WebSockets, GraphQL, and now recently async APIs. And this list is going to go on expanding basically, because every now and then different technology entrepreneurs or leaders, they see challenges in the existing technology and they try to overcome those by introducing new technology. And we all know any new technology will take some time to mature, and that is the time when the hackers actually want to exploit the evolving technology landscape and gain more whatever it could be, enterprise data or IP violation or and so on, privacy, etc. Right. So this continuous changing nature of technology landscape in the API domain is one of the biggest challenges that we are seeing now. Third challenge is the fragmented API management solutions. We'll talk about API management in subsequent slides. Just to give a heads up, API management, as the name suggests, it basically revolves around all the different lifecycle events associated with API. And you need a dedicated component to take care of this, just like you have an app server, which does take care of the the web application. Similarly, we have for API, we need API management solution. So that basically sits, in at a central location and then manages all the lifecycle events of an API. So what is happening in this space is because it's decade old, and there are a lot of solutions that have come up from small startups to established enterprise vendors. And every vendor basically tries to showcase their solution as a unique and with feature-rich options. And in the process, they make it more custom. And that has brought in additional challenges in the API security domain. Because imagine for an organization which has multiple business units, and each unit has gone for, say, a different API management solution. So at a central location, if you have to apply some uniform policies across these solutions, it becomes a big challenge, because every solution has been brought out from different vendor. So it's all customized, and there's no standardization in the services. So this basically brings in additional challenge in the API security ecosystem. And the last and the biggest challenge, I would say, is the scaling of API security effort. Now, what is happening is developers have started liking, the microservice-based deployment, development and deployment model. Similarly, with Microsoft comes API, and what has happened is since they started liking more, all the features they're deploying is via the APIs, and new APIs are being deployed at a much faster rate, as well as the existing APIs are being enhanced, at a faster rate. And so this is what is a development movement. However, in parallel, if you look at and check what security is doing, the API security is doing, it's actually just trying to see the older versions of the API still. I mean, they're not able to catch up to the speed at which developers are deploying new APIs, enhancing the existing APIs. So apart from this, there's additional challenge of the deprecated APIs, right? So you have to ensure that the deprecated APIs are not published anymore, to the external world. So the security team is still busy with, discovering versions that are no more being used, no more being supported, but still they are published, they are exposed. So these are all basically add up to the challenge in the, API security domain. So with this, I think I hope I've given enough context in terms of what is the API security domain looking like. Now we'll go back and see how we are trying to solve this some of these challenges from different dimensions. Yeah, let's go to the
Just
next
one
slide.
point to add there is,
Yeah, please.
if someone is entering into this career with some development background, and trying to get their arms around how do I learn the API security best practices, all that, I would recommend starting with the REST APIs because that is where the majority of the growth is, and then work their way in the other areas. So that's just a strong recommendation.
True. Yeah, very good point. In fact, earlier it used to be SOAP, but now it's the REST which rules the world. Yeah. And in the real-time architecture, real-time APIs, I think WebSockets also is now slowly picking up. And I mean, just yesterday I was reading about async APIs, and that is also catching up now. So yeah, let's see. But yeah, as Mitesh rightly said, REST is actually ruling the world. So if you can start with that, you would be able to learn, because there's a lot of training material, as well as free videos, free blogs that is available in the open domain in the internet. Yeah.
Hey, Mohan, I have a few questions right now to stop. So I'm going to be this developer, or I'm going to be this marketing person who is told that they can automate everything by joining this with one of the SaaS apps with the others. And they're asked, hey, do you have an API which I can, use? Or so somebody says, no, we don't have API, but we've got webhooks. And then there are all these intermediary like Zapier and Pabbly Connect, and there are all these different vendors which help you connect one app to the other with this whole automation stuff going on. So for somebody who is like, what is the difference between API and webhook?
Okay. Well, they do serve similar purposes, I would say. I have used webhooks, but very in limited time, and these are primarily exposed by the tools. I mean, I would say it's like a old way of working, but I mean, APIs can be used in pulling, right? And webhooks can be used for pushing. So you basically, it's like publish and subscribe kind of model, right? If you have API, you can actually call the API. That means you decide. It's like a what do you call this? There's this dedicated terminology called event-driven architecture, and one more. I just missed that. So these two are parallel, architectures. Now, async API is basically trying to enhance the event-driven architecture, right? I would say the difference as such between API and webhook, it's primarily the way you implement it. Okay, APIs are the recent way of exposing the services and the methods around those services, and the webhook is kind of traditional way of exposing the same thing. Yeah, and both are used for automation these days. Yeah.
Okay, all right. Mitesh, you wanted to add something?
No, I think it's accurate. So to me, webhook is more like a listener. You're listening for something constantly, versus API is there for more interactive. Basically, it's an interface that is out there for interaction. for someone. So you can provide different sets of input, and it will provide you different sets of output based on its specification. Versus Webhook, to me, is you're listening for something specifically, and it's just constantly pinging you that, okay, this happened, this happened, this happened, something like that. So and that's the way to explain in simple language.
Thank you. Thank you so much. This is basically my reason for asking you was that everybody wants everybody to open their database like through APIs, and so they can interconnect and they can, automate, and they can, and everybody wants to do it with low code or no code preferably. And that's why there is this importance of having this API security and even making people aware that, you have to make sure, because now you're exposing your database. So let's go to the next slide.
Okay. Yeah, all right. So this is how a typical enterprise API ecosystem looks like. On the far left, you have client applications. It could be the mobile, tablet, or any other client application, which is calling the API. So the API traffic actually first is analyzed by Web Application Firewall, or WAF. And then, once it does its own checks, it basically passes on that to API Management Gateway. And in the API Management Gateway, they basically do, identity check. That means any authentication or any subscription key analysis or any token validation, etc. Niloufer, we are not seeing it full screen. Yeah. Okay. Yeah. Thank you. So from that validation at API management level, then the traffic goes to API security tool. And here, a deeper analysis, especially focused towards API security, is done. Okay, and then if everything was okay, the traffic then gets forwarded to API endpoint, and eventually, if there is any database requirement, the API endpoint interacts with the DB and gives the response back. At API security level, in case something is not correct, either the request itself is malformed or some malicious data has been being pushed through a request. In such cases, the API security domain stops the traffic at that point and then gives a error message, whatever based on the configuration that is done at the API security tool level. So, so that's basically the main flow. And then there are additional flows. As I said, when the request comes, API request comes at API management level, you need to do authentication / authorization. And that point, you need to use identity and access management services to ensure that the API identity service is complete and it's fulfilled. And if not, then appropriate error is given, and the requester is, requester will get the appropriate error, and then the flow stops there. Now, once this traffic is complete, the response is delivered, then the role of SIEM actually comes in. Imagine SIEM is primarily security information and event management. So it has its webhooks, or it has its own, agents sitting on all these different security and other components, which basically keeps looking at the logs and the events that are happening and pushes that to SIEM tool. So the purpose of this tool is basically to gather all this information and do some AI or ML, artificial intelligence or machine learning, or some other business logic, and come up with patterns, patterns which actually help the security team to see any potential attack or any exploitation of any vulnerability, and so on. So the moment SIEM actually, alerts something saying that, hey, you know what, the rule says if there are more than 5 records being retrieved from the database layer, it has to generate alert. And then the moment, as a security consultant, when I see such alert, then I keep track of that whole flow, starting from when who requested this, and all the way till the DB layer, and then I get a complete flow to analyze and do the incident handling, right? So that is the job of the SIEM component. And then we have DevOps tooling, which basically integrates at three different levels. It integrates at API management level to ensure that the API management gateway has knowledge about which new APIs have been deployed, what existing APIs have been enhanced, with a newer version, right? And then the DevOps tooling has to interact with API security tool to understand whether the API is mature enough to be deployed, right? So API security tool works through static analysis, through dynamic analysis, and tells the developer, hey, you know what, your API is not at mature, and this is the score. And this score is less than the threshold score that is required for deployment. And then the development team gets a feedback, they update, and they again come back, right? And then API security tells, okay, now the score is better, it is above threshold, I'm allowing you to deploy. And then you have the deployment, where in the DevOps tooling, you have CD pipeline or a deployment pipeline that basically deploys the new APIs or enhanced APIs in the API endpoint level. So that's how the interaction happens from DevSecOps tooling with the main API ecosystem. At API management gateway, apart from identity, there are a few other things that are required. Primarily, API gateway is of course one. Then API policy server. API policy server basically takes care of the whole life cycle of an API. The onboarding part, the enhancement parts, the other configuration related to API, as well as at the end offboarding part, right? If an API gets deprecated, API management and API policy server basically decides how to deprecate it so that there's lesser impact on the production environment, right? So that's basically the API policy server service, right? And the third service at API management gateway level that usually we find is a developer portal. Now, developer portal is basically a service which is meant for both internal developers as well as external developers. These days, we have a lot of open APIs. That means we expose some APIs, and then our partners, our vendors, they basically take those APIs and then further enhance it and use it in their respective platform. So their developers also need access to our API ecosystem. So this developer portal manages the access for both the internal as well as external developers. So these three different services, the gateway service, the policy service, and the developer portal service, all these are usually combined in the API management gateway level. The API security level service, API security service, is something that normally resides outside. So maybe we can go to the next slide and we'll talk about in detail the API security service.
So Mohan, when we talk about an API gateway, is this like a commercial service? Is this something that is, how is this deployed across the organization? If you can just talk a little bit about
yeah, sure. Good question. In fact, there's a lot of confusion around this part, So usually it's a component that sits, if you've seen the diagram, right? Maybe if you can show that slide, I can explain better.
Sure. I'll just pull that up.
So if you see, it actually sits in the central location for the overall management of the APIs. So it is an external service, or it can be internal service. Depends, how your organization is deploying these APIs, right? So imagine you are in cloud, so you would probably deploy it in one of your cloud tenants, and then that would give services to your APIs. Now, sometimes you may have to support APIs, external APIs. Okay. In such cases, also you can use, you can expose this management gateway for the for supporting managing external APIs as well. Yeah.
So it's basically just to add to that, right? Yeah, I think where this API management space is heading is it used to be more like a proxy or just getting an incoming request that is internet facing, and it used to be appliances or a logical server that you can deploy as a software. However, going forward, and in fact it's already there, is that it's no longer just a proxy component. It is actually part of the security defense in depth, because the API gateway itself has now security services, as Mohan mentioned. So, and from the cloud perspective, pretty much all cloud providers provide that as a service. So it's just like you go to cloud provider and say, I need storage, I need servers. Similar to that, you can say, I need an API gateway. So it's just as simple as that, basically.
Right. So yeah, that's exactly correct. All the cloud service providers provide API management service, as out-of-box service, as well as there are vendors outside. They also provide dedicated API management gateways, and both are evolving. There are some challenges on both sides, but yeah, compared to what Mitesh said, the earlier phase of API management was primarily to do the reverse proxy part, but now it has evolved and it has started adding more features like, as I said, the gateway part, the policy part, developer portal part, as well as some part of API security as well. So yeah,
and
hopefully
it
in the near
actually
future,
takes
yeah.
Yeah, it takes some burden away from the developer also, because it can do rate limiting and do some specific transformation of data that if you have sometimes even a protocol difference, right, where you have a legacy SOAP and now you want to leverage the REST as your front end to interact with the customers because you have a better security model for REST, then you can leverage API gateway. So it has come a long way and pretty much a central point of focus when it comes to defense in depth, where web application firewall rule has been dramatically reduced because API management gateway is now offering some of those features. So it's just an important part is web application firewall often, when in the context of API, it can only do some generic stuff, versus API gateway has the context of your API because there is also a proxy defined on that. So it can do more or more custom controls versus what web application firewall can do for API.
True.
So, like, basically your authentication happens at that API management gateway level, right?
That's right. Usually, the identification, right, the API identity service is provided external to the API management gateway. I mean, in some cases, they attempted to combine it, and that messes up a lot of things. Usually, enterprises have their own IAM service, either internally hosted or cloud service provider, or the external vendor service, right, like Okta, ForgeRock, etc. So these services usually stay out and provide the identification as well as authentication and authorization services to the API management gateway.
Okay, perfect. Do you want me to go to the next slide?
Yeah, please. Yeah, here we're talking about how the so in the last slide I talked about, right, at API management gateway level there are a lot of functions that are now as it has evolved, it is taken care of, right, like portal, the developer portal, the service services actually, as well as the gateways, right, as well as a part of API security. So here I'm talking about how the API security actually has been spread out at different levels, because it is appropriate to handle these areas at those different layers in the overall enterprise network. And that gives us, as Mitesh rightly said, the defense in depth, for the APIs. So when the client traffic comes, for APIs, first layer is your web application firewall, and at that layer, you can take care of DDoS kind of attack. DDoS is distributed denial of service, as well as WAFs are generally very capable of handling uh, web-based attacks, or I would say the generic OWASP web top 10 attacks. So those are really matured, and they provide really good service at a WAF layer, that is at the entry level or at the gate level for the enterprise network. However, it has not matured enough to take care of supporting API security. Although few vendors have started offering API security at a WAF level, however, the maturity still is not there. Uh, and then the traffic comes to the API management gateway, where, as I said, part of the API security is handled at this layer. So as Mitesh talked about, rate limiting, throttling, as well as taking care of authentication, authorization, token management, subscription tokens, etc., as well as token validation. When the request comes, it validates a token if it is the correct token used by the subscriber, whether it is still live or not expired yet. Those kind of validations are done at the API gateway level. And once these things are sorted out, then the traffic is passed on to the next layer. And this is the most sophisticated API security layer, I would say, because here it has full knowledge about the data that is coming in through requests. It has full knowledge about the path at which it is trying to hit, as well as the JSON schema, as well as the open API specification schema, basically, right, or the contract rather. So this sitting at this layer, API security tool actually can validate very in depth, right? Apart from this validation, it can actually help analyze from the security side internal traffic and external traffic. So what is this internal and external traffic? So when we talk about external traffic, that means traffic coming from outside, it is usually referred as north-south traffic. That means from external layer, it has come inside, and then you have in endpoint actually serving to that request. And API security tool monitors that traffic and the requests as well as responses, and checks if there are any security challenges, right? So that's the external traffic. Similarly, there is an internal traffic. That means we call it as east-west, where an API which is called by the external user depends on another API for its whatever business requirement fulfillment, right? So and that API is internal API, or it may again depend on multiple few other APIs. So this traffic between the APIs which are behind, or which are inside the enterprise network, we call that traffic as internal traffic, or east-west traffic, right? East-west is internal and north-south is external traffic. So both these traffics can have security vulnerabilities, right? And the API security tools configured at this layer can actually analyze better, because it is at the gate level, I would say, so they are best placed to analyze both the traffics and provide validation services. Apart from that, in the next few slides, we'll see, there are some specific attacks that happen only in the API domain, right? So API security tools are configured for this niche requirement, or niche validation. So API defense in depth is covered in, this API security tool or layer 3. Yeah. So this way, basically, a defense in depth is achieved for security testing. Apart from that, the other two layers, right, the API endpoint layer, the database layer, they have the traditional security, right? Validating any input that is coming from untrusted source that is implemented at API endpoint level, as well as at the DB layer, you have disk encryption or field level encryption or masking for sensitive data, as well as some other procedures are written to ensure that those get triggered based on certain conditions, right? Or I've seen in some organizations they implement kill switch. That means if there's excess data that is being retrieved, which is more than usual data, kill switch gets triggered and the database gets completely disconnected from the API endpoint. So all these different layers basically give us a very good defense in depth if properly configured. Yeah.
So Mohan, when people ask me what is a WAF and what is a RASP, like this API security tool, which is like a RASP, right? Runtime protection. So the difference is like wearing gloves, which is your WAF, which helps you so that things don't go inside. And then once if they've gone through that, your RASP or your runtime protection is like a vaccination, which is trying to help you once the traffic has or something has bad has come inside the environment. Is that a good way of describing the difference between the API security tool and the WAF?
Yes, you can say that very well. In fact, see, WAF or Web Application Firewall is, at the end of the day, it's a firewall, right? So if you see the history of how the WAF has evolved, earlier we used to use network level firewalls, right? And once we saw the applications are evolving with a lot of data, so there was a need felt because the network firewall actually works only at the network layer, right? And then as and when the attacks were seen at the application layer, and they were although any attacks through network layer were blocked by network firewall, but the attacks at the application layer were actually going through smoothly. And that's where more context specific firewalls came, and that are basically known as web application firewall. That means it works at a layer 7 at application layer, and then it knows the expectations basically in terms of how to detect application level attacks, right? Because it has a context around it, and each application you can configure at WAF level, saying that okay, these are my requirements, and then you can onboard or enroll that application on a WAF. So WAF can actually cater to web application or application level attacks very effectively compared to the network firewall, right? But again, what we saw, WAF is also lacking some of the, lacking ability to stop some niche attacks, right? So that's where the RASP came in actually. RASP is a real-time application self-protection. So that works next to where your server is deployed in the production, right? It actually goes through, it basically takes a copy of, there are different ways of implementing RASP. It takes the traffic or takes a copy of the traffic, analyzes it real time, and then it works the closest way compared to WAF, or compared to network firewall with the application layer, right? And since it knows usually what ports are open, what commands are executed, what processes are normally required, right? So if it has basically a profile of what application usually does, and then since this RASP tools have that very close knowledge about how applications work with all these profile details, anything above and beyond this profile, it basically stops the request at that point in time, right? And then RASP tools can be configured to to do some additional checks which are context specific. That means imagine a request has come which has bypassed WAF, which has bypassed any other firewall and other layers and come to the API endpoint or web server. Okay, and you have this RASP running, and then this request basically is trying to create a new port or calling a new process or starting a new service. something of that sort, which is not there in the profile of that runtime, for that application profile, right? So immediately the runtime protection tool kicks in and then says, hey, you know what? This looks unusual. Let me start giving additional validation. So maybe MFA is asked. Maybe I'm just giving an example. So this is the closest protection compared to all other traditional layers, right? So RASP, because it is closest to the application, it can actually cater to each request level validation, right? Better than the other layers. So in this context, in the API security domain, yes, API security tools are working at different layers. I'll cover that in the next slide, in fact. So one of the dimensions of API security tool is giving protection at runtime, just like a RASP. Okay, so this tool basically has all the necessary knowledge about, as I said, the data, path, schema, okay, the expected error codes or a success code like 200 OK or 403, 404, etc. And because these tools actually have given the feedback to the development teams have actually configured their implementation to respond to each of these different error codes. If it is 200 OK, everything is OK, respond, right? If it is anything 200 other than 200, you actually have a configuration fix saying that, okay, if it is say 300 or say 404, this is the error message you give. So you don't even process the request at API security level itself. You send the response back saying that, you know what, request is not proper for this reason, right? So you basically avoid processing load at the API endpoint by securing your responses at the runtime protection layer or API firewall layer. So some of these tools they refer instead of runtime protection, they call it as API firewall, because that's the additional layer which is sitting next to the API endpoint. So you can call it as RASP, API firewall, or API security tool in production. All these are basically same. So they have more better niche context either to the web application or to the API endpoint, so that it can protect more closely. Yeah. I hope I answered your question.
Yes, you did. Thank you.
Okay. Okay. So so we understood the API ecosystem. We understood how the defense in depth works in the API domain. Now let's understand how these tools, API security tools, should work, right? And as I've said in the disclaimer, it is borrowed from 42 Crunch model. This is one of the vendors. Again, I'm saying use your judgment. This is not an endorsement. Okay, so don't sue me later. So here, the tools, API security tools should ideally work at these three modes, in audit mode, scan mode, and protect mode. When we talk about audit mode, here we are saying I'm a developer. I'm developing API. I have already ready open API specification contract or a Swagger file. Okay, and then I'm implementing, right? And while I'm doing that, if I get a feedback saying that, hey, you know what, you have implemented it everything correctly for success flow, but for unsuccessful flow, for example, what if there is 501 or 404 or 403? You don't have any implementation for it. So it gives a feedback and developer immediately implements it, right? And then similarly, hey, you know what, the data type validation is missing for this API method, right? So immediately the developer says, okay, yeah, that's fine. Let me add that validation, and then he moves ahead. Now imagine, instead of getting this feedback here at the ID level, you get the feedback at a later layer, right? A later layer, when I say, I mean during pen testing, right? So what has happened is, over a period, the there's a gap or a time that has spent between the developer and the pen testing, so development activity, commit, etc. And then you have all the other activities, right? You have functional testing, performance testing, security testing, all these in an automated CI/CD model, and then you have deployment, and in test environment, pen testing comes and they do the analysis, and then they give a feedback, right? So this feedback is relatively late in the system. It can be days or it can be weeks in some organizations, right? So if you get an ID level feedback, this whole time that you're wasting gets actually reduced to zero, right? So developers can actually get security feedback, and they can improvise the code and fix those issues at a ID level during development itself. Similarly, the API security tool should work in the CI/CD level as well. What I mean by that, I mean build breaker or gatekeeper way. That means statically, when I committed my code for an API method, or it's a new API altogether, once I commit, I have the CI and CD, the continuous integration and continuous deployment or development pipelines, right? So these pipelines basically check during its execution, check with the API security tool and say, hey, you know what, give me certification whether this is okay to go ahead for deployment, right? And then the security tool actually gives a feedback and says, hey, you know what, for security, this is the ranking, or this is the marks out of whatever. It could be out of 10, out of 100 or whatever. And for data security, this is the feedback. And these two feedbacks basically, help us as an organization to do this check automatically and transparently, right? So the moment the threshold, so imagine I'm expecting minimum score of 80 for the API deployment, and the score is 75. Obviously, the automated pipelines will break the build, and a developer get a feedback saying that, okay, the necessary score has not been met, and that's where the build was broken. And he gets a complete feedback saying that these are the possible areas where you can actually improvise and fix the issue, right? So in audit mode, the static analysis basically helps development teams to get a feedback and fix those issues at a very early stage, like a shift left stage, I would say. And this next important model is the mode is the scan mode, right? In scan mode, what happens for every given API, once you deploy it in a test environment, this API security tool should go ahead and fuzz it, or attack it, just the way an attacker is trying to exploit various vulnerabilities present in an API, right? And this, we call it as a dynamic scan, for an API security tool. So the dynamic scan is basically you have X number of fixed, I would say, requests, and each request basically has malicious payload, as if attacker is actually attacking. And these fixed requests, like hundreds or thousands, just go on bombarding onto the API, which is already running in the test environment, right? It is just like an automated pen testing, but it is done by a tool, right? Of course, it has its limitation compared to manual pen testing, but still this mode actually gives us a very good feedback in terms of where the shortcomings are, right? So there are a few things that are missed by static scanning, which are covered by dynamic scanning, right? And this combinedly, audit mode and scan mode, gives a very good feedback to the development teams well early, before it gets deployed in the production. And the last is the protect mode. This we talked about, during RASP. So it's basically runtime protection as API Firewall or as RASP. So this basically, sits in the production environment, and it keeps looking at the traffic that is coming from WAF, API gateway, and then this tool, basically API security tool running as a RASP or API Firewall. It analyzes the traffic, it checks all the OWASP API security top 10, it does all the other additional checks, and then it either forwards valid traffic to the API endpoint, or gives an error response back to the the requester. So that's how usually API security tool should work, in an enterprise level. So these are, I call it as opportunities for us, for the security team to integrate at different levels, so that different stakeholders can actually get benefits, from the early feedback. Yeah.
So
Yeah.
So Mohan, basically, This audit mode is like when you are developing something, then the scan mode is more like when you are testing, and then protect mode is when it goes live.
Correct. Absolutely correct. Yeah, that's right.
Okay, thanks.
Yeah. So, yeah, let's wait for this. Yeah. Okay. OWASP API security top 10. So this is just like in the earlier sessions we heard of OWASP web app security top 10, right? Similarly, since APIs are gaining prominence across globe, at enterprise level, uh, OWASP actually felt the need to have documented the niche attacks that happen in the API domain, and that's how this API security top 10 was born. And it was released in 2019. I think in this year probably we may get the second version. So this was the first version released, by the way. So if you look at the list of these top 10, you would find some of these are appearing in mobile app security as well as web application security top 10 list as well. Because when you're deploying, you're working at app layer, right? At a layer 7 in the OSI model. And so obviously, some of the attacks are going to be common, right? So if you look at API 7 to 8 and 9 and 10, these four are, you can see it in across in the web security, in the mobile app security. These attacks are common. However, where they get targeted is different. In the API domain, security misconfiguration, for example, is targeted towards various components which I showed earlier in the API ecosystem. It could be WAF, it could be API management gateway, it could be identity service, it could be even at API security tool layer as well. So any misconfiguration done at any of these components in the API security domain or API domain can be exploited. So that's why it has appeared there. Now, if you look at API misconfiguration, you can find it in web application security top 10 as well, where the components which are responsible to give web application service gets targeted, right? So misconfiguration at component level is the main motto for bringing this vulnerability in the top 10, right? So based on where you're looking at, either web, mobile, or API, you should basically look at securing the configuration at various components that are there in your respective area. Now, coming to API 1 and to API 6, these are the niche attacks that we have observed. I mean, the OWASP team has observed towards the APIs, and these you don't find common in web app or mobile app security top 10, right? So these are the ones which the API security tool, a dedicated API security tool, usually targets, to prevent any attacks. So you in the last four, WAF is partially configured. API management gateway is again partially configured to take care of it. But if you look at API 1 to 6, this has to be taken care by a dedicated niche API security tool, right? So I don't want to give more details on this because this itself would be a 1 or 2 hour session, OWASP API security top 10. So I've given the link there. You can go to that and understand more details. In the next slide, I have given some video links as well, which will give you even more additional information about how these attacks are getting exploited in the real world, right? So we have seen APIs exposed by Facebook, Twitter, Starbucks. All the top organizations have been found vulnerable to one of these top 10 API security vulnerabilities. So so it's not that only startups have these issues. No, even the established organizations can go wrong in the API domain. And that's why whenever I get an opportunity to talk, I basically stress on this. In API security or in API domain, it's very easy to go wrong. in the API implementation. So it is very, very important that you have some strategy to take care of API security. Otherwise, one single API call, you know, which is vulnerable in exploiting a vulnerability, can bring down or dump the whole database, right? So if you're not careful, mass assignment, excessive data exposure, these are the attacks which actually can bring the whole database out in one call, right? And we have seen it, and if you just go to the resources and refer some of the webinars and some of the videos, you will actually come to know that it has happened in real world. They have given the examples with the names, how it happened, etc. So yeah, just refer to those links there. Yeah, maybe you can go to the next slide. Yeah, so this is a partial list again, right? Because I have only limited space here. So yeah, I've given the links for OWASP API Security Top 10, as well as OWASP has other links where cheat sheets, test guides, etc. are given. So you can just explore the OWASP.org and you can get a lot of information, to understand the API security domain, and then how to work in it, for identifying, testing, and fixing those vulnerabilities. I have given link for one of the 42friends.com videos, the webinar videos. This gives a very good information about, how the real world attacks have happened, which are exploiting all the OWASP top 10, and it gives a very good view of, what was the vulnerability, how it was exploited, and what was the result, and how it can be fixed as well. So that links basically, I mean, I really like the content there, so that's why I've given there. Again, it's from a vendor. My disclaimer is it's not an endorsement, so please don't misunderstand. I've given links for Open API specification, as well as OAuth 2.0 and OpenID. So when it comes to APIs, it's very important, for a developer, for a tester, as well as for a researcher to understand, the authentication and authorization that goes in, the API implementation. And that's where one needs to understand deeply how OAuth works, how OpenID works, and which are the right use cases to apply, OAuth and OpenID, right? So there are links which, I've given, which can give you more detail about those. I've also given pragmaticwebsecurity.com resources HTML link. Again, it's from a training vendor, but the resources are really good. And since there is a lot of confusion in terms of clarity of OAuth 1.0, 2.0, OpenID, where it should be applied and where it should not be applied, so the link actually can clarify a lot of those doubts, right? Then there are some API security newsletters, webinars. You can go through it. Very good resources, and I really enjoy reading APIsecurity.io, because almost every week they send this newsletter, to cover what has happened in the API security domain for that week. It could be new approach to API security, or it could be new hacks, which cover different API vulnerabilities actually in the real world. So you get a good view of what has happened in that week for API security. And of course, there are a lot of videos in the YouTube. Just few days ago, Cathy Paxton Fear, she has actually presented in the OWASP series on API security, and I've given the link. It's a very good session. I think more than 1,400, 500 people saw that video, and liked by many actually. And I really like that whole video. So do go through these links, and yeah, you can explore further, for a deeper understanding. Yeah.
So
And from the
yeah.
Just to add one thing, so we mentioned earlier that if someone wants to transition the career into this, then REST API start there, and that's where the Open API specification is heavily relevant. And I strongly recommend that even though it may be somewhat perceived as out of scope, but they should really understand the Swagger structure and the specification as much as possible, because that will help as a practitioner, help where things can go wrong and how to correlate those things with the OWASP top 10 of API and all that. So it's something to keep an eye on as the specification matures further.
True.
Sure.
Yeah.
And this Pragmatic Web Security has a free course on OAuth 2.0 and OpenID, and it is like really good. So please go, and if you are interested, please make sure that you go through that course. It will provide you with practical lessons also. Again, so I highly recommend it.
Yes. Okay, now we got basic understanding, we got learning resources, where to look and learn. Now, how do we get started, with API security? So what I would suggest is, first start, don't talk about API security. First, start with basics, like how do you do the functional testing of an API, right? And then if you understand that well, you can always mature to the next step, that is the API security testing, right? So you get familiar with the ecosystem about functional testing of APIs, right? So you have tools like Postman. Again, it's not an endorsement. That's a widely used tool. Catty in the last session, she recommended all these other tools. FUF, Kite Runner, Zap is there, Burp Suite, both community and pro edition. These tools are definitely useful in the journey, API functional testing as well as API security testing. As well as there are Burp Suite add-ons, which are available in both community and pro edition. I haven't used it, but Cathy has recommended, so I've just pasted it here, called Authorize and Infuel. So these add-ons actually help in attacking a niche area, in the API security domain. And there are many more add-ons. So you have to just explore, and Portfigure's site, the Burp Suite site, also gives lot of resources, to explore these add-ons, as well as use basic features that are provided by Burp Suite. Similarly, Zap has also a lot of resources in the open source domain. Yeah. So once you are thorough with this basic understanding of how APIs work, how to do functional testing, and then you can look at the API documentation or Swagger or the Open API specification contract, right? And you understand how it is being configured. So Mitesh was talking about understanding Open API specification, right? And that understanding basically helps in this at this stage, because once you understand that, which are the areas to target in the shortest possible time, so that you can make optimized use of your resources. And once you have that, then you are ready basically. So then you start with fuzzing or any injection attacks, or of course OWASP API security top 10 attacks, right? And see if you can find something. And if you're able to find something, like some vulnerability, you do your own analysis. You understand what this can do actually, impact wise, whether it can impact only one API, or it can impact only one customer, or it can impact the whole enterprise database, right? So because this impact is the one which basically changes the criticality of your vulnerability, right? More the impact, more will be the criticality of your vulnerability. So it can start from low, medium, high to critical, or even super critical kind of, So once you understand the impact of the vulnerability that you have identified, you understand how to fix it as well, because eventually you may have to talk to a development team who owns that API. So you may have to guide them as well. So it's not just okay to have knowledge of finding vulnerabilities. It's equally important to help development team to remediate or fix those vulnerabilities as well, right? The last part is once you found it, how do you disclose it? So my recommendation is do it in an ethical manner. just share it with API owner and provide the remediation as well, on basically how to fix the vulnerability that you have found. So this is basically how a new entrant actually can transition. Look at the API, look at the API, functional testing tools, get familiar with it. Look at the Open API specification, get familiarized with the Swagger and the other contract that API exposes. Then you take the next step of doing the security testing or API security testing with all the fuzzing, injection techniques, and all the API security vulnerability list, and see if you can get it. Yeah. So that's how you basically get started. Yeah, we can go to the next slide unless there's some question. Probably this is the last slide. So now that as a new entrant, I've learned the basics. What next? I mean, this slide is common in the last session as well. So best part is to get yourself registered in the bug bounty platforms, because these platforms bring two main participants onto one platform. One, the researcher, that is you, who's willing to spend some time, effort, and bring out some vulnerabilities. Second, the enterprises. So these enterprises actually want their applications, APIs, or mobile apps to be tested thoroughly enough, because normally what happens in the pen testing, you get limited time, like 1 week or 2 weeks time only, right? Within that time, the pen testing team has to do a lot of coverage of their test cases, and so there's a kind of limitation and a sense of urgency to complete the pen testing within that period of time. In the bug bounty, there's no such limit. So organizations get benefited, because a researcher can spend like 1 day or 1 week or even 6 weeks to find a very critical vulnerability, right? Because they spend more time, they understand the platform better, the API implementation better, and can identify very critical vulnerabilities, from the implementations. So researchers and enterprises actually, so both, come at a bug bounty platform and work together. So organizations or enterprises basically authorize these researchers to go ahead and do the whatever assessment, testing, and identify vulnerabilities. So you are authorized to do this. So I would suggest, as a new entrant, bug bounty platforms is the best place where you can show your skills, and if you're able to find some good vulnerabilities which are like high critical, etc., you can get very attractive bounties as well. And the last and most important point is, I talked about in the last slide also, the ethical disclosure. If you find some vulnerabilities outside bug bounty platform, right, in any of the APIs, disclose it only to its owner, and don't do it publicly, but do it privately, through their official ethical disclosure channel, and never ever publish your achievements in social media before it is fixed, right? So the ideal workflow is you identify vulnerability, you disclose it ethically to the owner of that API, and you give them some time, to understand whether it is actually a vulnerability or not. Then they may ask some guidance, to fix it if they don't know, and then then there's some time that you have to give it to the development team to fix it, validate it. They may come back to you as a researcher and say that, okay, can you check if it is valid, and fix, and then once the fix is in place, then you can check with them, can I publish this in the social media? And then if they are okay with it, just go ahead. And usually, the organizations are responsive. That means because you have put time, effort, energy into this, they either, give you a swag, or give you a bounty or a reward, or they may have a hall of fame, within their organization. So they may list your name there, and then you can actually, boost that in the social media. So this is how, you should disclose the vulnerabilities that you find in an ethical manner or in a responsible manner. and not immediately jumping, and going to the social media before it has been fixed. Yeah, with that, I end. If there are any questions, I think we can take it up.
Sure. So I don't see any questions
Okay.
at this time. So Mohan, would you be open to coming on, and Mitesh, you also, because if there are questions regarding very specific, like we talked about the OWASP top 10 API security, and more or less it like injection and misconfiguration, etc., seem to be the same, but there are certain specific things that will benefit people. So I'm just requesting you that you're open to that. And thank you so much for sharing all these. It's been a great 3-part series, securing apps,
Yes.
securing devices, securing the APIs. So if somebody, even if a developer or somebody else from general IT area is interested in transitioning to a career in mobile security, I think this is a great series of videos. Thank you so much, Mohan and Mitesh.
Thank you.
I really appreciate it.
Thank you.
Thank you.